Hello and welcome to yet another video of Cornerstones of Math. Today I am going to solve the following problem. Consider a 4x4 grid made of 16 identical squares. You want to color 8 out of these 16 squares. Find the number of cases in which exactly 2 squares are colored in every row and column. In this problem, each row and column are distinct from others, so you don't have to consider the rotation or flipping of the grid. Alright, so that is our problem, and just like many challenging problems, we start by considering the simplest case, a single row. Let us consider only one row for a while, which can be considered as the linear arrangement of 4 squares. How many ways are there to color 2 squares out of these 4? This process is the same as arranging 2 colored squares and 2 uncolored squares, and we can find a number of cases like this. First, we consider them as 4 different elements and arrange them linearly, which give us 4 factorial ways. However, these 2 colored squares are indistinguishable, so we have to divide this by 2 factorial, which is the number of ways to arrange these 2 colored squares labeled 1 and 2. Similarly, these 2 uncolored squares are also indistinguishable, so we have to divide by additional 2 factorial. This gives 6 ways. Now, if the problem were a simple linear arrangement problem where you had to find the number of ways, the solution would end here. But we are also considering columns in a 2-dimensional grid, and in order to deal with that, we actually have to find and sketch all 6 possible arrangements in a single row. We are going to use these in the next part, so let's give names to these arrangements: A, B, C, D, E, and F. Then you can construct a 4x4 grid by choosing 4 rows out of these 6 and arranging them. You can choose the same row multiple times. Now we must find out which combination of rows A to F will result in a grid that contains 2 colored squares in every column. Well, one example is AAFF combination, which clearly gives 2 colored squares in every row and column. Other arrangements using 2 A's and 2 F's also work, such as AFFA, but I will deal with that later. Another example is BBEE combination. Any arrangements of 2 B's and 2 E's do result in a grid with 2 colored squares in every row and column. And you may have well understood what I'm doing right here, so let me just display the entire possible sets of rows. There are 6 of them: AAFF, BBEE, CCDD, ABEF, ACDF, and BCDE. These are all possible letter combinations, and now we have to arrange the letters, that is, arrange the rows within each group. 3 groups at the top, that is, AAFF, BBEE, and CCDD, consist of only 2 letters, with each letter being used twice. Therefore, for each group, there are 4 factorial divided by 2 factorial 2 factorial, hence 6 ways to arrange the rows within the group. Meanwhile, 3 groups at the bottom consist of 4 different letters, with each letter being used only once. Therefore, there are simply 4 factorial, that is 24 ways to arrange the rows within each group. Therefore, the number of cases is 3 times 6 for the top groups and 3 times 24 for the bottom groups, which gives 90 ways. And that's all for today's video. Thank you all for watching. If you enjoyed this video, please go press that like button and explore other videos on my channel, and I will see you in another video.